Hello to everyone. In this session, we have to discuss about problems on D'Alembert's ratio test. So problems. The first question is test the nature of the series summation n cube plus 9 divided by 2 raised to n plus 9. So nth term is an is equal to n cube plus n plus 9 divided by 2 raised to n plus 9. An plus 1 is equal to n plus 1 whole cube plus 9 divided by 2 raised to n plus 1 plus 9. So here we have to replace n by n plus 1 in an. Then consider an plus 1 by an. We get n plus 1 whole cube plus 9 divided by 2 raised to n plus 1 plus 9 into 2 raised to n plus 9 divided by n cube plus 9. So at numerator, so for in first term we take an n cube outside. At denominator 2 raised to n plus 1 can be written as 2 raised to n into 2 plus 9 into. So second term we taken 2 raised to n outside into 2 raised to n into 1 plus 9 by 2 raised to n. At denominator we taken n cube outside, so we get 1 plus 9 by n cube. Then so apply the limit on both sides as n tends to infinity. So after simplification and apply the limit as n tends to infinity, we get half, that is less than 1. So by D'Alembert's ratio test, the given series is convergent. Next problem. Test the nature of the series summation 2 raised to n plus 1 divided by 3 raised to n plus 1. Solution. So here the nth term is an is equal to 2 raised to n plus 1 by 3 raised to n plus 1 and an plus 1. So you replace n by n plus 1 in an. Then consider an plus 1 by an. So after simplification we have an plus 1 by an is equal to, at numerator we taken 2 raised to n outside, so we get 2 plus 1 by 2 raised to n. At denominator we taken 3 raised to n outside, that is 3 plus 1 by 3 raised to n into, in second term we taken 3 raised to n outside, so we get 3 raised to n into 1 plus 1 by 3 raised to n, and at denominator we taken 2 raised to n outside, so we get 1 plus 1 by 2 raised to n. Next, apply the limit on both sides as n tends to infinity, so we get 2 by 3, so that is less than 1. By D'Alembert's ratio test, the series is convergent. Next, test the nature of the series summation 1 by 3 plus 1 into 2 divided by 3 into 5 plus 1 into 2 into 3 divided by 3, 5, 7 plus 1, 2, 3, 4 divided by 3, 5, 7, 9 up to infinity. So the nth term of this series is an is equal to 1, 2, 3, 4 up to n divided by 3, 5, 7, 9 up to 2n plus 1. So an plus 1 is equal to, just here we have to replace n by n plus 1, that is 1, 2, 3, 4 up to n into n plus 1 divided by 3, 5, 7, 9 up to 2n plus 1 into 2n plus 3. So then we have to consider an plus 1 by an. So we get an plus 1 by an is equal to n plus 1 by 2n plus 3. At the denominator we take an n outside, and at numerator we take an n outside, and similarly at denominator we take an n outside, so n get cancelled. Then apply the limit on both sides as n tends to infinity. So after applying the limit, we get half. So that is less than 1. By D'Alembert's ratio test, the series is convergent. So next problem, test the nature of the series 3 by 2 plus 3 into 7 by 2 into 4 plus 3 7 11 divided by 2 4 6. Then solution, the nth term of the series is, so 3 7 11, so nth term is 4n minus 1 divided by 2 4 6, its nth term is 2n. Then an plus 1 is equal to 3 7 11 up to 4n minus 1 into 4n plus 3 divided by 2 4 6, so 2n into 2n plus 2. So then consider an plus 1 by an, so we get, so 3 7 11 4n minus 1 into 4n plus 3 divided by 2 4 6 up to 2n into 2n plus 2 into 2 4 6 up to 2n divided by 3 7 11 up to 4n minus 1. So we get an plus 1 by an is equal to 4n plus 3 by 2n plus 2. So here at numerator we take an n outside, and at denominator we take an n outside, so n get cancelled. So then apply the limit on both sides as n tends to infinity. So after applying the limit, so we get 2, this is greater than 1. Then by D'Alembert's ratio test, the series is divergent. Next, test the convergence of the series 1 plus 1 factorial whole square by 2 factorial into x plus 2 factorial whole square by 4 factorial into x square plus 3 factorial whole square by 6 factorial into x cube up to infinity, here x greater than 0. Solution. Here rejecting the first term, we consider the nth term as an is equal to n factorial whole square by into x raised to n divided by 2n factorial. Then an plus 1 is equal to, so n plus 1 factorial whole square into x raised to n plus 1 into 2 into n plus 1 factorial. So we have to replace n by n plus 1 in an. Then an, consider an plus 1 by an is equal to n plus 1 factorial whole square into x raised to n plus 1 divided by 2 into n plus 1 factorial into 2n factorial by n factorial whole square into x raised to n. So after simplification, we have an plus 1 by an is equal to n plus 1 into x. Then apply the limit on both sides as n tends to infinity. So here we take an n outside, that is limit of n into 1 plus 1 by n into x. So we get, after applying the limit, we get infinity, that is greater than 1. By D'Alembert's ratio test, the series is divergent. Next problem, test the convergence of the series 2 by 1 square plus 1 plus 2 square by 2 square plus 1 plus 2 cube by 3 square plus 1 plus up to infinity. So the nth term of the series is an is equal to 2 raised to n by n square plus 1, and an plus 1 is 2 raised to n plus 1 by n plus 1 whole square plus 1. Then we have to consider n plus 1 an plus 1 by an, so that is equal to 2 raised to n into 2 divided by n plus 1 whole square plus 1 into n square plus 1 by 2 raised to n. We get an plus 1 by an is equal to 2n square plus 2 divided by n square plus 2n plus 2. So after simplification, we have 2 plus 2 by n divided by 1 plus 2 by n plus 2 by n square. So here we take an n square outside at numerator and denominator. Then we have to apply limit on both sides as n tends to infinity. So we get 2, that is greater than 1. Therefore, by D'Alembert's ratio test, the series is divergent. So in this session we had discussed on D'Alembert's ratio test. So these are the reference books for used to this session. Thank you one and all.